In this video, we discuss proportions and rates, which are ways of presenting dichotomous data. As we're interested in their application to describing health and disease, we'll pay particular reference to understanding the terms prevalence and incidence and their distinction. Prevalence is a type of proportion, while incidence is a type of rate. Let's first see an example. So here we have data on HIV/AIDS from Western and Central Europe and Oceania. The first column gives the number of people living with HIV/AIDS at one particular point in time, in this case at the end of 2007. In the second column we have the number of new HIV infections, and lastly we have the population size, and for clarity this is expressed in thousands, and that's often done to save writing loads of zeros. So the number of people in Western and Central Europe is 486 million. So clearly these are different population sizes, so how can we describe and compare these numbers better? Well, we can first of all give the percentage of people with HIV in each region. So at the end of 2007, 760,000 of 486 million people, or 0.16%, were living with HIV in Western and Central Europe. We can also look at the rate of new infections. In 2007, there were another 31,000 new cases of HIV. This equates to a rate of 6.4 new infections in every 100,000 people per year. In these two calculations, we've just computed what is known as the prevalence of disease and incidence of disease. These two terms come from epidemiology and are two different ways of quantifying health in a population. And you can see that the prevalence of HIV/AIDS is fairly similar in Western and Central Europe versus Oceania, relative to the incidence of disease in these two populations. The incidence is far higher in Oceania, and we'll come back to this in a minute. Prevalence measures the proportion of people in a population that have the disease or some other quantity at a particular point in time. So it's a number of people with a disease divided by the total number at risk, and it's typically expressed as a proportion or a percentage or a number of cases per 10,000, 100,000, etc., whichever is clearer to present. So in the earlier example we looked at the percentage of people living with HIV, and in that example it was reasonable to assume that everyone was at risk in the population. So that was our denominator. There are two common types of incidence. First, there's the incidence rate. This is the rate of new cases of a disease or outcome. It's calculated by dividing the number of new cases by the total person years at risk. The denominator can be a little confusing. In the HIV example, we use the average number of people that were living in each region in 2007. The assumption was that this is the number of people who were at risk over that particular period in the year 2007. In some studies, we would try to estimate the person years at risk, such that for each individual, we work out the amount of time they were disease-free from a given starting point. We then sum across individuals to get the total person years at risk, and then that is used as a denominator. However, the concept is the same. If there are an average of 100,000 people in a population in 1 year, then that is conceptually the same as 100,000 person years. And it's obviously not feasible to define person years exactly on an individual level in global studies such as the HIV example, and it would be futile to try and do so. But the important point is that the measure is a rate because it includes a unit of time. The cumulative incidence is slightly different. It's used when we have a known group of healthy individuals and follow them up over a period of time. We then calculate the proportion who had the outcome during that period. The cumulative incidence is also called the risk, and it's used in studies where there is a fairly captive sample, such as a clinical trial. So for example, if we do a trial comparing two drugs, A and B, and follow them up for a period of 6 months, recording occurrences of the outcome, the proportion of the original sample with the outcome in each of the two groups over the 6 months is the cumulative incidence, or the risk. And whenever we report a cumulative incidence or a risk, we should always report the time period over which it refers to. So we would say something like, of those treated with drug A, 5% experience the outcome over a 6-month period. Prevalence can be roughly related to incidence by the following formula. So if the incidence or average duration of disease increases, so does the prevalence. A bathtub analogy is often used to think about the relationship between prevalence and incidence. So the flow of water into the tub represents the incidence, while prevalence is represented by the proportion of water in the tub, and cases leave the prevalence pool by either being cured or through death. So a balance of factors may affect the measure of prevalence. As an illustrative point, parity in the prevalence of disease between two populations does not necessarily reflect parity in the health of those two populations. So if we look back to the HIV example, where there was a fairly similar prevalence of HIV/AIDS comparing Western and Central Europe to Oceania, but there was a much higher incidence in Oceania, 40 versus 6 per 100,000 people per year. One explanation might be that the duration of the disease is longer in Western and Central Europe due to better treatment and longer survival. Hence, the prevalence pool appears similar relative to a population with a much higher incidence. And here's a list of terms introduced in this video.